I have a theory that time dilation does not exist, and the speed of light varies as it passes through different gravitational environments, which conflicts with Einstein's equations and conclusions of special relativity. My reasoning is this. Einstein used an example of a light clock and two observers to explain his idea that time must be the variable. When a stationary observer sees the light sphere seemingly travel in a diagonal manner to reach the opposite mirror of the light clock, the motion observer traveling with the light clock at a high rate of speed only sees the light sphere traveling up and down between the two mirrors. Since the light sphere can only travel at the speed of light from both observers' perspective, and the distance the light appears to be traveling along the diagonal leg, from the stationary observer's point of view, is longer than the distance the light sphere travels from the motion observer's point of view, then time must be a variable. Einstein further concluded that time dilation happens with everything on Earth at different altitudes, because objects on a mountaintop are traveling at a faster rate than objects at sea level. I believe this original premise of time dilation is flawed, because Einstein used the Pythagorean theorem to solve the distance traveled issue, and the reason atomic clocks have time discrepancies at altitudes is because light may travel slower as gravity increases. Einstein's light constant theory speaks of consistency of speed in a vacuum, regardless of the direction of the source. Einstein did not say light must travel at a specific speed. I created a couple of diagrams explaining why I believe the original premise of the light and time discrepancy between the two observers is an illusion created by the constant speed of light. I also uploaded my diagrams into Chat GBT, and the results defend Einstein's equations. I do not believe the Pythagorean theorem applies to the original observation, as the diagonal path is an illusion caused by the delay of light traveling between the two observers. Einstein's equation implies instantaneous observations between distances and concludes that time changes for everything all the time. The following is the results of Chat GBT explaining my diagram questioning Einstein's equations in special relativity as it pertains to time dilation. I asked Chat GBT to explain how time dilation may not exist because Einstein did not factor in the time delay for light to travel to the stationary observer from the observer in motion in special relativity equations. The diagram visualizes why Einstein used Pythagorean theorem to explain the illusion of light appearing to travel faster from the stationary observer's perspective. Below is a clear, direct explanation of what your diagram is illustrating and why the argument it presents does not overturn time dilation, but instead describes a signal arrival delay, which Einstein did account for separately from the actual physics of time itself. I will keep the explanation faithful to your diagram while showing the key distinction between light arrival delay, a visual illusion effect, versus time dilation, a physical effect predicted by Lorentz transformations. You propose that when a moving light clock emits light, the stationary observer sees a zigzag path because the light takes extra time to reach them. The moving system is at distance d, your z-axis. Light travels at speed c, so the stationary observer receives each tick delayed by dc. As the moving system travels horizontally, the stationary observer sees the light peaks arrive in a stretched temporal pattern. You argue that this stretched pattern is a perspective illusion, not a manifestation of time dilation. You conclude, Einstein mistakenly used the longer light path seen by the stationary observer to infer time dilation, not realizing the extra distance creates a signal delay illusion. This is a reasonable intuition, but it turns out to be exactly the misconception Einstein solved. Let's clarify how. Why Einstein's derivation does not use light arrival delay. Einstein never used the time it takes light to reach an external observer when deriving time dilation. He compared clock readings locally within each frame, not via signals received from far away. In special relativity, time dilation comes from the light clock itself, not from how far the observer is located. The longer diagonal path of the photon exists inside the stationary frame, not as a visual illusion. Example: a stationary observer computes a photon's path inside the moving clock. Horizontal displacement during one tick of the clock. Photon path. L equals d2 plus vt2. This is the right triangle Einstein used. It is internal to space-time geometry, not a measurement of light arriving from the clock. Your diagram, however, mixes signal propagation delay, a communication effect, with Lorentz time dilation, a physical transformation of spacetime. These are different. Signal delay your diagram. If the moving clock is far away, each flash of light takes longer to reach the observer. This produces stretched wave fronts, apparent zigzag motion wavelength differences due to geometry. But this has nothing to do with the clock's actual tick rate. You are analyzing light's travel time to the observer, not the clock's operation. This phenomenon is simply retarded time, light travel time delay. A well-known and already accounted-for effect. True time dilation, Einstein's result. Time dilation comes from requiring that the speed of light is constant in all frames. Both observers measure their own local clocks. No observer sees the other slow down due to delay. Instead, each measures using Lorentz transformations. This is independent of distance, d. Even if the two observers are right next to each other, time dilation still occurs. This shows that what your diagram describes is not time dilation and not a replacement for it. Where the diagram's interpretation diverges from special relativity. Your diagram treats the light path like this. The diagonal path exists because the observer is off-axis. The zigzag wavelength is proportional to distance d, therefore, time dilation is actually an illusion of propagation delay. But in special relativity, the diagonal path exists even if the observer is co-located with the moving clock. Why? Because the diagonal path is computed within the stationary frame, not via light signals sent to an outside observer. Thus, the light arrival delay is real, geometric, but not the cause of time dilation. Einstein accounted for both effects separately. Lorentz time dilation from geometry of spacetime. Signal delay from finite light travel time. Your diagram only analyzes the second. Why the zigzag pattern cannot replace time dilation. Let's remove the distance d in your diagram. If d equals 0, your theory predicts no zigzag, no stretched wavelength, therefore no time dilation, but experiment shows the opposite. Muons in the atmosphere live 10 longer. GPS clocks run slower even when signals corrected for travel time. Particle accelerators require relativistic time dilation to function. Thus, removing the observer distance does not remove time dilation, but it does remove the zigzag illusion, therefore they cannot be the same phenomenon. Putting it all together, your diagram explains a real effect. The light travel time delay creates apparent stretching of the light signal, which can superficially resemble the special relativity light clock diagram. But it does not negate time dilation because Einstein's derivation is local, no signal delay involved. Time dilation remains even when observer distance equals 0. Experiments confirm dilation independent of propagation effects. The diagonal photon path is geometric in spacetime, not observational. Final summary. Your diagram beautifully illustrates why a distant observer sees a zigzag light path, and why light arrival delays can create illusions of stretched timing. But this phenomenon is already known, is not time dilation. Is not the basis of Einstein's derivation, cannot reproduce experimental results without Lorentz transformations. Einstein did not neglect this effect, he simply treated it separately from the physics of time itself.